Hello, welcome students, and today we are discussions of the resistance when they are connected in a series combinations. And in the previous lectures we are just discussions about the one of the electrical equipment, that is the rheostat, and that previously we are just discussed resistors. There are two electrical equipment, and the third one is we are just discussed, that is in these lectures we are discuss the resistance when they are connected in a series combinations, that is resistance or resistor when resistance connected in series. What is the series? When there are number of resistance are connected in a series, that is same electrical current passing through the each individual resistors or same path of the each individual resistors. The resistors are connected in series combinations. In series combination, they are connected in series combination. I will be drawn one of the diagram here. Consider this is the electrical path when they follow some current, that is this is the battery I will be connected here, and the current will flow in this directions. The current flowing through the circuit is I, and I will be connected to different resistors. That is one, this is called as R1 resistors, and another resistors, that is R2 resistor. This is the R2 resistors. The current flowing through each resistors will be same, that is same electrical current, flow through each resistors. The current flowing through the resistor number 1 R1 and resistor number 2 R2 will be I, that is the same current flow, that is I current flow through the each resistors, but the potential difference are V1 and V2 for R1 and R2 resistors. R1 and R2 resistors respectively. That is, for the resistors R1 we are connected the potential difference, that is V1. For the resistors R2 we are connected another one potential difference, that is V2. In the series combination, the supply voltage V1 and V2 are divided, but current remains same. I will be written one of the useful sentence, that is in series combination, supply voltage, that is V1 and V2, supply voltage divided, but current remains same for each resistors. Current remains same for each resistors. For each resistors. And this is the all about the circuit diagram I will be drawn here. What are the in some terms in the circuit diagrams? I will be connected one of the battery, the positive terminals here and negative terminals are on opposite sides of that, and I will be supply one of the current. This current is I will be flowing through the this point. I will be consider point A and this is the point B. This current will be flowing through point A to point B. In the path of that current or in the path of A to B is we have connected two different resistors. The resistor number 1 I will be name, that is R1. Resistor number 2, that is name is R2. In the two different resistors, the current will be flowing same for each resistors and they are connected in a only single path, connected in a same path. This is called as, this is the series resistance. The resistors are connected in a series combination, same electrical current flow through the each resistor, that is I. Same electrical current flow the each resistor, that is I. The potential difference are V1 and V2. The potential difference, that is V1 and V2, are connected for the R1 and R2 across the R1 and R2 resistors respectively. In a series combination, the supply voltage are divided. The supply voltage are different for each resistors, but current remains same for each resistors. This is the all about the circuit diagram what will be connected. According to one of the laws, according to Ohm's law, we know that Ohm's law V is equal to I into R. In this form, we are consider some terms about the resistors. Then I will be drawn the proper, I will be use the proper meaning or proper equation for the resistors. That is, rearrange this formula. Then R is equal to V upon I. That is, R is equal to V upon I. For the resistors 1, that is R1 is equal to V1 upon I. I will be same for the both resistors. Consider this is equation number 1 and R2 is equal to V2 divided by I. This is the equation number 2. Then total resistor, total potential difference, that is total voltage in the circuit, that is two voltage are applied across the resistors R1 and R2. The sum of both voltage, this is the total voltage of that circuit. Then total voltage, that is I will be drawn V is equal to V1 plus V2. V is equal to V1 plus V2. According to the Ohm's law, the equations 1 and 2 becomes, I will be write V is equal to I into R1 plus R2, and these equations I will be write here. Then V1 is equal to I R1 and V2 is equal to I R2. And this equation, these both equations, that is I will be left hand side V1 and V2, and in these equations I have the V1 and V2, and these both equations are situated on that places, and use these equations and we get the one of the different equations. This is the all about which we are use the voltage, and the equivalent series resistance R, equivalent series resistance, that is RS is equal to R1 plus R2. And I will be use one of the sentence by using these equations or the conclusions of these equations. The equivalent voltage is the sum of all voltage which are connected in a series form of given circuit. That is, one another times, the equivalent voltage of the given circuit is equal to the sum of all resistance which are connected in the series form of the given circuit. And I will be use this same equations for the n number of resistance. I will be connected number of resistance, the n number of resistance, then Rs is equal to R1 plus R2 plus R3 plus dot Rn. This is the equation for the n number of resistors are connected in a series form. This is the all about when we are use some resistors are connected in a series form. What is the series form? The current of flow of each resistors will be same but different potential difference. This is all about. And I will be solve one of the problems. Then I want to draw one of the diagram for the solving of the problems. Consider two different resistors are connected in a series form, or three different resistors are connected in a series form, that is R1, R2 and R3 are three different resistors. The value of these resistors is 10 ohm, 25 ohm and 40 ohm. What are the equivalent resistance in between? The current will be same, what are any current, and the potential difference is difference for each resistors, that is R1, R2, R3. We are use the proper way for solving the problems. I will be write given R1 is equal to 10 ohm, R2 is equal to 25 ohm, R3 is equal to 40 ohm. We write the equivalent resistance of the resistors are connected in a series form. Then the equivalent resistance Rs is equal to R1 plus R2 plus R3. The equivalent resistance of the given circuit is when the number of resistors, that is R1, R2, R3 are connected in a series form, then Rs is equal to 10 ohm plus 25 ohm, that is R2, and 40 ohm is R3. Let's find the equivalent resistance. Rs is equal to 75 ohm. 75 ohm. This is the equations. This is one of the problem I will be take here for the reminding of series equivalent resistance which are connected in a series form. This is the all about when the resistors are connected in a series form. In the next lecture we are just discussed when the resistors are connected in a parallel form. What is the parallel form? Consider this is the one of the resistance and one of the circuit diagram, and these two different resistors are connected in here, and these resistors are in a parallel. R1 and R2 are the parallel to each other. This is the one of simplicity and raw diagram, not a proper diagram. I will be shown here what are the, I want to clue you, that is what are the combinations of parallel combinations of resistance.